Okay, in this lesson we want to look at solving rational equations. So one of the ways to solve for a rational equation is to follow these steps. The first thing that we want to do is we want to factor all of our denominators. Okay. After we've factored all of our denominators, we're going to find any excluded values. Now, the way we know that it's an excluded value is we're going to find our domain. If we think, it's been a long time since we talked about domain, but all that means is what we want to do is we want to set each of the denominators equal to 0. And what we're saying is that they cannot be that number. So if we end up with, say, for example, we have a denominator that's x plus 3, we'd set that equal to 0. We'd say, hey, you know what? It cannot be that number. So x cannot be negative 3. Say, for example, we had a denominator where we have x minus 1, and we have x plus 5. All right, so I'd set each of those denominators. So x cannot be 0. X minus 1 cannot be 0. And x plus 5 cannot be 0. So therefore, we have x cannot be 0, x cannot be 1, and x cannot be negative 5. So that's what I mean by excluded values. We're going to set each denominator equal to 0, but then we're going to say it cannot be that value. Okay? Now, those we just kind of leave alone for a little bit. We're not doing much with that until we get to the very end. We'll see that again. Okay? So, now what we want to do, looking at these denominators that we have factored, we want to find the LCM, remember that least common multiple, and then we want to get all of those rationals to be that least common denominator. Okay, so that's kind of what we were looking at last week. Once we've done this, then we're going to simplify and solve the numerators only. Okay, numerators only. After we've gotten a solution, say we get x to be 7, then we're going to go back to those excluded values and say, okay, well, I got 7. As long as we said that x cannot be 7, then we're okay. If we did say that x cannot be 7, then I would say that that is an excluded value. Another word for that is an extraneous solution. Remember, we looked at that before. So basically what happened is we got that number, but when we go back and check it, it actually is something that should be excluded. So therefore it's an extraneous solution. So it will not be included. All right, so let's look at some examples here. Okay, we've got our first example here. We've got 3 over k squared minus 2 over 3k equals 3. So the first thing that we want to do here is we want to go through and we want to say, okay, well, let's factor all the denominators. Nothing needs to be factored, so we're already ready to go to the excluded values. So I'm going to set each of those denominators equal to 0, but we're going to say it cannot be that. So I'm going to say that k cannot be 0. 3k cannot be 0. So again, we get k cannot be 0. So when we look at our last one, 1 over 3, 3 cannot be 0. That doesn't even make sense. Okay, so really the only excluded value that we want to see here is that k cannot be 0. So I'm going to write this here. Excluded values is that k cannot be 0. Okay, so we leave that aside, and now we're going to go solve. Now, real quickly, I noticed as I was looking at this, I made a little mistake here. I want that to actually be an 8, so let's change that real quick before we move on. All right, sorry. That does nothing to the denominators. It'll just affect my final answer here in a little bit. All right, so now that we've got those excluded values, we're going to find that least common multiple, that least common denominator, and get everything set to go. All right, so I look at this and I say, okay, I've got a k squared, I've got a 3k, I've got a 3. What is that least common multiple? What is that least common denominator going to have to be? So I'm going to need to have, for my least common denominator, a 3k squared. That will include everything in the denominator. And so that's what my least common denominator is going to have to be, right? Moving forward, we say, okay, well, what would we need to multiply each of those fractions by? Well, the first one's going to have to get multiplied by a 3. The next one's going to have to get multiplied by 8k. The last one's going to have to get multiplied by ak squared. All right? Now, when we do this, and we get all of this to have the least common denominator, so I'm going to have 9 over that 3k squared. I'm going to have minus 8k over 3k squared equals k squared over 3k squared. So now that I have that each rational has that LCD, now what I'm going to go do is I'm going to go through and say, all right, I'm going to simplify and solve the numerator only. All right, so I'm going to take just my numerator here. I'm going to say 9 minus 8k equals k squared. Okay, so I'm going to keep solving it. K squared. So since I have a square, that means I need to set it equal to 0. So I'm going to move this 9 and this 8 to the other side. Okay, in doing that, I'm going to have 0 equals k squared plus 8k minus 9. I'm going to go ahead and factor that. So I'm going to have k plus a 9, k minus a 1. So I'll end up setting each one equal to 0. So I get k to equal negative 9 and k to equal 1. All right. Once I do that, I'm like, okay, great, I had this answer. Well, no, wait a second. I have to go back and I have to check to make sure that these two solutions that I got, k equaling negative 9 and k equaling 1, are not what should be excluded. So I check it back. As long as I don't get 0, then I'm okay. So since neither of these were 0, I can include both of those as my solution. Okay. So let's look at another example. Go a little bit quicker through it since hopefully now we've got kind of the idea of what's going on. Okay, first thing I want to do is I'm going to factor. This one does need to be factored. I'm going to have a 5 and then I'm going to have an x plus 3. So I'm going to now look at those excluded values. So I'm going to say x plus 3 cannot be 0. 5 cannot be 0. Well, that didn't make sense anyways. And then I've already done that x plus 3 and that 5 over here. So I'm going to say x cannot be negative 3. That's the only excluded value that I have so far. Okay. And I say that's the only one because, remember, the x cannot equal 0. Well, yeah, that doesn't make sense. And I would solve the next ones, but I've already done that. Okay, I've already used the 5 and the x plus 3. All right, so leave that alone for a minute. Let's go solve our equation. Okay, so I look at all of my denominators. I've got an x plus 3, I've got a 5. I've got a 5, I've got an x plus 3. So I'm going to get that least common denominator is going to be 5 times x plus 3. Okay. So now I need to see, okay, well, what am I going to need to multiply by? The first fraction is going to need to get multiplied by a 5. The second fraction is going to need to get multiplied by an x plus 3. But the last fraction already has all of it, so I don't need to do anything to it. All right, so let's see what that's going to look like. I'm going to get 20x over 5 times x plus 3. I'm going to get 7x plus 21. I'm just distributing that over that 5 times x plus 3. And I'm going to get 2x over 5 times x plus 3. All right, so now that they all have the common denominator, I'm going to simplify and solve the numerator only. All right, so now I'm going to look at this 20x plus 7x plus 21 equals 2x. So let's go ahead and simplify that. I'm going to combine my like terms. I'm going to have 27x plus 21 equals 2x. I'm going to move this 27x to the other side. So I'm going to get 21 equals negative 25x. Divide by that negative 25. So I think that x is going to equal a negative 21 over 25. And you're like, oh my gosh, it's a fraction. Okay, well, that is perfectly fine to get a fraction. As long as I do not get this negative 3. So, right, I got to go back up to my excluded value. And I'm going to say, okay, as long as the answer I got is not negative 3, I'm okay, which it is not. So, therefore, I have my solution. Okay. All right, so let's look at a few more examples here. Looking at this first one here, number 3, we are going to first see if we can factor. There's nothing to factor, so I'm going to move right into my excluded values. I'm going to take that x plus 1, say that it cannot be 0. I'm going to take that x plus 2, say that it cannot be 0. So my excluded values are going to be x cannot be negative 1 and x cannot be negative 2. We're going to leave those until the end. We're going to make sure that we do not include those. All right? So now we're going to look at what would we need to get to be able to find a least common multiple, that least common denominator. So we are going to need an x plus 1 times an x plus 2. All right? I'm going to need to multiply the first one by an x plus 2. So multiply that by the top and the bottom here. The next one, we need to multiply by an x plus 1. Top and bottom here. The last one, we need to multiply by an x plus 1. Top and bottom. So multiplying the numerators here, I'm going to end up with 3x plus 6 over that common denominator plus 4x plus 4 over that common denominator. And I'm going to get 15x plus 15 over that common denominator. Now that they all have that least common denominator, I'm going to solve the numerators. So I'm going to have that 3x plus 6 plus 4x plus 4 equals 15x plus 15. All right, I'm going to combine those like terms. So I'm going to have 7x plus 10 equals 15x plus 15. I'm going to solve for x here, so I'm going to move that 7x to the other side. So I'm going to get 10 equals 8x plus 15. Move that 15. And then finally divide by 8. So what I think is the answer, I think that x is going to equal negative 5 over 8. As long as I check against my excluded values here, and indeed it is not one of those two excluded, so that is my solution. Okay, let's look at another one here. Okay, first thing I'm going to do is I'm going to try to factor. I can actually factor on this one. I'll need to factor to be an x minus 5 and an x plus 2. Now I'm going to look at those excluded values. So my excluded values, I'm going to get x minus 5 cannot be 0, so x cannot be 5, and x plus 2 cannot be 0. So I'm going to get x cannot be negative 2. All right, leave those alone for a second. Now I'm going to go back and I'm going to find that least common multiple to be able to get my least common denominator. So that one is actually going to be x minus 5 times x plus 2. So I have to ask myself, well, what am I going to need to multiply the first fraction by? I'm going to need to multiply by an x plus 2. What am I going to need to multiply the next fraction by? I'm going to need to multiply by an x minus 5. And I look at the last one, it already has the common denominator, so I don't need to multiply by anything. So let's see what that's going to look like. I'm going to distribute here, so I'm going to get x squared plus 2x over that x minus 5 times x plus 2. Plus distribute my 3x minus 15 over that x minus 5 times x plus 2. Then that 7x stays over that x minus 5 times x plus 2. All right, now that I've got the common denominators the same, I'm going to look at my numerators. So I've got x squared plus 2x plus 3x minus 15 equals 7x. Let's combine some like terms here. We've got x squared plus 5x minus 15 equals 7x. I'm going to go ahead and set this equal to 0 since it's a quadratic. So move that 7x over. So I'm going to get x squared minus 2x minus 15 equals 0. Factor it up. I've got x minus a 5, x plus a 3. So that would leave me that x should equal 5 and x should equal negative 3. Now, I got to go back and I'm going to check my excluded values say that x cannot be 5. But that's what we got. So therefore, that makes this an extraneous solution, because it was an excluded value. Okay, so we've got a little vocabulary there. All right, so now the only solution that I can actually have on this one is that x is equal to negative 3. All right, last one. Let's make sure that we've really got what's going on here. Okay, I'm going to try to factor. This one I can factor. So I'm going to factor that x squared to be x plus 3, x minus 3. Now I'm going to go for my excluded value. So I'm going to set x minus 3 cannot be 0, and x plus 3 cannot be 0. So my excluded values say that I cannot be 3, and I cannot be negative 3. Okay. So now we need to find that least common multiple to get my least common denominator here. So my least common denominator is going to be that x plus 3 times x minus 3. So let's see what I need to multiply the first one by is going to be an x plus 3. The next one already has everything that it needs. So now I'll move on to my last fraction here. I need to multiply by an x minus 3. Okay. So now that I've done that, move it up a little bit, get some more room. So now that I have done that, I need to go ahead and distribute. So I'm going to end up with 6x plus 18 over that x plus 3, x minus 3 equals 8x squared over that x plus 3, x minus 3 minus 4x times x minus 3. Now remember, this is a negative, so when I distribute that, I'm actually going to end up with a plus a negative 4x squared plus 12x over that x plus 3, x minus 3. So now that I've got the common denominator here, I'm going to take just my numerator, so 6x plus 18 equals 8x squared minus 4x squared plus 12x. All right, so I'm going to combine my like terms. I'm going to get 4x squared here plus 12x. This other side was already combined. Now I'm going to set it equal to 0 because I notice I've got an x squared. So I'm going to get 0 equals 4x squared. I'm going to move that 6x over, which is going to give me plus 6x. Move that 18 over, which will give me negative 18. All right, so one thing I noticed that they have a GCF, so they can all be divisible, or they can all be divided by 2. So I'm going to go ahead and reduce that. So I'm going to end up with 2x squared plus 3x minus 9. So now I need to solve it, so I need to factor it. So I'm going to factor this, and I'm going to end up getting the factors 2x minus 3, x plus 3. All right? Set each of those factors equal to 0. So I'm going to end up getting what I think is my solution, but I'm going to have to check it. So I think that one of my solutions is 3/2, and I think that another solution is -3, right, when I solve those. So I'm going to go back up to my excluded values. But my excluded values up here say that I cannot be -3. So I actually can only use that answer of 3/2 or 1.5, whichever way, because this is what we call an extraneous solution because it was an excluded value. So it's very important that I go through and I check my answers against those excluded values to know if I have something extraneous or not, or I've done all of that work just to get the answer wrong. So very important that I go back and check those answers.